My name is Brandon, and I'd like to start today by telling you a story. The year was 2005, and a bright-eyed web developer who was entering his 5th year of his career was spending a lot of his time working in the world of cross-browser support. And as we all know, from those of us that worked around those days, we can remember that we didn't tend to concern ourselves much with patterns and frameworks and standards much in those days. It was a hard life. Really often, the toughest thing about living in that world was getting something to work reasonably well across Internet Explorer and Firefox and Safari. So it was a tough time. So imagine the excitement of that young fellow when he heard about this amazing thing called Ajax, asynchronous JavaScript and XML, sort of the dawn of the new web in 2005, 2006. Now, the technology behind this had been available in Internet Explorer since around IE 5.5, but the dawn of this term, when this term was coined, a lot of people were implementing this set of technologies across browsers and coming up with clever hacks to get this working in other browsers and really doing some amazing things that was moving us away from the world of round-tripping back to the server with every page refresh and into adding interactivity into our sites. So imagine that developer's surprise when he got Jquery Ajax for the first time and all the wonderful things that introduced. And the problem is Jquery Ajax was great. Now, everything that we were doing with async code, though, in those days really came with a lot of traps. Those traps really were the fault of the callback. And in a year, in 2009 and 2006, in a year that had a Nickelback song that was featured in the top 100 in the United States, and a X-Men movie that made Wolverine spend the next 10 years trying to, that caused Hugh Jackman to spend the next 10 years trying to kill off Wolverine, we also had the callbacks. Now, callback, the idea behind a callback was great. This was our way in those days to deal with asynchronous code that we didn't know. At some future point, we needed to make a request. We needed to get some sort of response back. This was the state of the art at the time. But those of us, again, who have lived in those days and worked in that era knew, and we know, how quickly things like this would get out of hand. Callbacks, nested callbacks, were a mess. And this is every web developer from 2006 to 2009. This was our worst nightmare. And we knew from almost the beginning that we needed to do something about this. And so there was a lot of work from 2006 on, and especially around the end, around 2009, where we started to do more to really think about how can we solve this problem of callbacks and yet still deal with the magic of asynchronous code and the sorts of dynamic interactivity that we wanted in our applications. And thus the idea of promises was born. Now, promises, the concept of promises is a concept in computer science that's been around since 1976. But in the context of JavaScript, it was around 2009 where we really started to think about using this as a way to help manage the kind of asynchronous code that we were writing. And the whole point here with promises is that it allows you to create a proxy object that represents the future state of some unknown value. So you defer the ability, you defer your own management of the return of an async call or some sort of other unknown future interaction to another object to manage that state for you. And a lot of why we have promises in JavaScript today is due to the CommonJS group and the standards body that in 2009 was formed around this idea of getting back to improving the JavaScript language. Now, again, those were dark times in the early 2000s. And even in 2009, we were still at a point where there wasn't a ton of work going on in standards bodies, not only within the browsers and their capabilities, but within the JavaScript language itself. But as some of you may remember, 2009 was also the year that Ryan Dahl introduced Node.js. And so there was a need, there was interest in the community to spend a lot more time thinking about how we could actually implement better alternatives to callbacks, not just in the JavaScript language, but to make that available in our browsers. And we had that. I mentioned Jquery Ajax. Jquery Ajax was promise-based. Dojo Deferred was the first implementation of a promise-based framework inside of the browsers. And then in the common JS body, there were actually 5 separate, one abandoned and the 4 that I've listed here, 5 separate promises implementations or specifications that were put forward. So there was a ton of interest here. And thankfully, because of the interest in HTML5, and I love this because it's actually been years since I've gotten to put an HTML5 logo up on a slide deck, but I got to do it today because I'm giving you a brief history here. But it was the interest in HTML5 all the way from Google to Safari to Mozilla through Firefox and ultimately Microsoft with IE9 and beyond, where we got interest in improving our browsers and improving the JavaScript language, improving CSS, improving every aspect of the web development experience. And so where we are with promises today, this better alternative to callbacks, is that any browser not named Internet Explorer has full support for promises, even the mobile browsers, and it's of course in Node as well. So very briefly, for anyone that hasn't had a chance to really work with promises before, in the context of formal promises support in the JavaScript language, every promise represents 1 to 3 states: pending, fulfilled, and rejected. When a promise is created, that's its initial state. It's pending. And then at the execution of some interaction, a lot of times it ends up being an Ajax call, an API call, or something like that. At the end of that execution, that promise is either fulfilled, it completed successfully, or it's rejected because there was some sort of error. And one of the great things about promises, which takes us a little bit out of that world of callback hell, although you'll see in just a minute it's not perfect, although it is better, is that we can actually chain promises together. This is actually, in many cases, we owe thanks to this from the promises A specification in CommonJS, what was referred to as thenables. The idea of a thenable is a promise that allows you to chain its interaction to cascade into another asynchronous call into another interaction. So the formal promise object has a couple of prototype methods for then, for catch, for finally, and by chaining together responses, we can pass information down the line to dependent interactions. So in this case, I'm calling an API to get a collection of devices. Once I get that device, I can get an individual device by name. And then these chains of API calls can all happen, and I can reasonably tell what's actually going on and what comes out the other side. I also have the ability with promises to bubble up my error handling into one catch that occurs at the end of that chain of results. And this is, again, a nice, clean way of working with callback-based APIs. Because the reality is that under the covers, believe it or not, promises are basically just hiding the ugliness of callbacks from you. It's nice, but it is still ultimately a little bit of syntactic sugar. But the benefit of that is that we can then take something that's callback-based that we're probably not going to get updated to being promise-based anytime soon and actually wrap it in promises ourselves. And one great example of that is the Geolocation API in the browser. It's going to be callback-based for a while because of backward compatibility. But if you're working with it, it's actually something that you can mess with in order to see what it looks like to work with promises and actually to be able to work with those on your own, and then wrap something that's more friendly, more geolocation-based for you to use. So I've got a simple application that just does a couple of things. The first thing I'm going to show you is what it looks like, the traditional way of working with the Geolocation API. Hopefully this is a blast in the past for many of you, blast from the past. So I call navigator.geolocation.getCurrentPosition. And this takes 2 things. It takes a success callback and it takes an error callback. It's a very common pattern for things that were created around this time. And that's it. Navigator geolocation to get current position. If it succeeds, execute this callback. If it fails, execute this other error handler. And then where I'm going to call that actually inside of my application, I'm just going to call geolocation dot, what did I call it? Oh, wait, that's in the wrong place. Pardon me. I go in here. Locate. Geolocation dot callback locate. And then I will pass in, this is where I'm actually going to specify my handlers. Now, thankfully, with new ES6 language features, I can actually just use arrow functions to make this a lot cleaner. But what we would do back in the day was we would just, function, parameter, open and close. But here I'm just going to take and log out the position for the success. And then in the case of the error, I'm going to log the error. And that's it. So when I go to my wonderful application here, which, oh yeah, this is what I get for closing the terminal right before forgetting that I actually needed something in there. So bear with me for just a second while I run this demo fail. Where's my directory? Pardon me. Figure out where I'm based there. Presentations. All right. Oh, come on. Everybody got any good jokes? You seen any good movies lately? Development. Presentations, addition callbacks, there we go. And I can do npm run start. Oh, come on. npm run serve. And maybe, okay, there we go. Wonderful little version. I just wanted y'all to know that I know how to start an npm server anytime I need to do it on demand in front of 40 people. So if I click locate me, it's going to run my callback-based code, and I should get a response there. I've got my coordinates. That's great. That was callback-based. So again, wonderful. We're not here to talk about callbacks. We all know callbacks. It's a wonderful thing that we have gotten much more improvement on in the context of promises. So what I'm going to do is I'm going to re-implement that. And I'm just going to wrap it in a promise. So there's still callbacks that are actually happening here. But the beauty is, again, I'm allowing that to be handled internally by promise. So in this case, I'm going to do return new promise, not a processing instruction. And then every promise needs a resolve handler and a reject handler when you're creating one on your own. And so in this case, now that I've got that, I have a resolve and reject. Now I'm going to call navigator.geolocation dot get current position, and I'm going to call resolve and reject, and that's it. So now I've wrapped this in a promise. That's great, wonderful. I've added more code. What does this actually get you as someone that is calling the geolocation API? What this enables you to do on the other end now is I can call geolocation dot promise locate. In this case, I'm not passing anything in, and then I'll call then, and here I get my position. And I'll do console.log position. And then a catch for the error. Console.log error. Right? Now, if I run that, I will get the same result again. So there are my coordinates. Now, in terms of what this saved you is, when you're making a single call, it may look like, okay, it's syntactic sugar, and ultimately it is. There are callbacks behind the scenes. But what this ends up being very useful, as I showed in the slide earlier, when you're starting to chain things together, when you have dependencies between APIs. So I want to actually take a second to look at that, because I think that's when things look a little bit more interesting. So who uses promises? A lot of modern APIs that work with asynchronous code, especially now, implement promises. You find very few things that are being maintained now that still use callbacks. Again, some browser-based APIs, they do. You can wrap them. But one example that I'll share today from personal bias is from Particle. So I work for Particle. We are an IoT hardware and platform company. And so I spend my day actually building things with hardware devices. So I build connected conference badges and things like this with blinky lights and cellular and Wi-Fi solutions and things like that. And this is relevant. The world of JavaScript development is relevant to us because we provide SDKs. We recognize that for developers that are building connected solutions, reading from a sensor or controlling an actuator is not something that you want to keep embedded on that board itself. A lot of times these projects need to post sensor data out to the cloud for processing, or they need to expose functionality to a web app or to a mobile device. And so we provide SDKs for iOS, Android, and Windows. And then my personal favorite, we provide a JavaScript SDK as well. And where this ends up being really useful is when we're building solutions at scale, a lot of times we need to control individual devices without being able to mess with and touch every single one of these at a time. So this badge that I held up earlier, we actually created this for our booth at the Bay Area Maker Faire in California last month. And we created 11 of these for staff to wear in the booth. And I wasn't going to go and touch every single one of those as people were trading off and picking up the badge to work in the booth for 3 or 4 hours. I wanted to put their names on the badge while they were wearing it. And so we're able to use cloud APIs and asynchronous JavaScript code ultimately to update these devices and give you real-time information. So with all of that as background, I want to show you actually what that looks like in the context of working with these particle devices and our cloud API ultimately. So I'll start by showing you the particle console because this will make sense in just a moment. But the particle console is where you manage all of your individual online devices. So you can see the devices that you have named. Because I do this all day long, I have like 3 screens worth of connected devices. And then when you look at an individual device, you can get information about it. But one of the cool things, again, I mentioned, because of the Cloud API, you can expose functions on that device. So this particular device is actually an LED light panel that's in my office back in Austin, Texas. And I can show local weather on it or set the text to high and call that. And this is actually going to go and set that panel. I promise. I don't have a video camera set up in there, so you'll have to believe me. But it'll actually update the text on that panel. I can show animations and things like that as well. And everything that you have available here inside of this console is available via our Cloud API and then ultimately available via our JavaScript API as well. So like a lot of JavaScript-based APIs nowadays, you can install that via NPM. You install the API via NPM, and then you have the ability to use the functionality exposed by the API. And if you'll notice, the text on the left here is our functions in this library all return promises. So this is a promise-based library. You'll notice in some of these cases that the way that we've implemented many things is it's promise-based, also providing a second parameter error handler, which you can do that as a callback, or you can actually wrap, like I'll show you in just a second, and do that yourself. So again, having this at my disposal, and now what that allows me to do inside of this project, inside of my little demo app here, is that I can actually do some things like getting the list of all of my online devices. So again, we're talking about promises here. So when it comes to getting my list of online devices, I'm going to return a new promise. I'm going to do resolve reject like usual. And then I'm going to call the particle API. So you'll notice here that I've brought it in, I've instantiated it. I have my token hidden from prying eyes. And then you can call list devices. And then for list devices, I'm going to pass in that token. And then I will call then. So with this, now what I'm going to have is I'm going to have a list of devices. So this is where I will call resolve. Resolve is my way of saying I'm done. You can set the promise now to a resolved state, and anything that is calling it, you can call its then handler, right? And then in the case of catching an error, I will do reject. And that's it. So now, if I go back to my wonderful, fantastic little demo page here, and I click on Get Particle Devices, I've done a console table. By the way, it's cool little console feature that if you don't have a ton of data like I do, you can do a console table and actually get the data nice and formatted in any array. It just gets formatted for you automatically, so cool little tip. But I can actually see my devices that are online here. I can see that whether it's connected, it is connected. But I also have a list of 24. That's a few too many. So I'm going to use the power of promises to now do my next step. I have that list of devices, but I want to filter that down. I only want to show the devices that are actually connected. So you all don't have to continue watching me type these things over and over again. I actually already have this here. But in the next case then, for getting just the online devices, I'm calling the API. I'm getting my list of devices. So you remember, list devices is promise-based. It is itself returning a promise. And when it resolves its promise, I now have a list of devices that I can then resolve after filtering out just those devices, calling the filter method on the device's body array, and just getting those devices that are connected. So now when I call this will get me just a list of 15. But you'll notice when you look at this, inside of my list of 15 devices, and this is a common pattern when we work with APIs. APIs tend to be shaped very efficiently. We try to keep them small for a reason. But that is what tends to lead us into cases where we have dependent asynchronous calls that need to happen one after another. What I really want to know right now is the same information that's here in the console, which is what are the functions that are available on this device. But if I look at what's actually being logged here, I don't have that information because I need to make a second API call. But in order to make that API call, I need to pass in the ID of a device that I have. So this is where we actually start to see promises making a little bit more sense. Now what I want to do is I want to call some of those device functions. And the way that this ultimately ends up working, again, I have a new promise. I'm listing those devices. And now for my first then with devices, I'm filtering to get down the name of the device that gets passed in. So let's assume in this case I have a name of a device but not an ID. So I have even an additional step there. I know the name. I need you to give me the ID based on that matching. So it finds the actual device by name. I have that device ID, which is returned to the next promise. That's my next ID, to my next then. So now I make another call against the particle API to get that individual device by the ID. I return that result. Now I've got another promise that has been resolved. And in this case, I have an individual device, and from here, I call resolve with device body functions. And the way that I call this in my applications, very simple. I just call particle.get device functions with the name of the individual device, and then console table that information out. So what this ends up looking like is this list of ultimate functions. What's interesting, and this is great, so I was able to use promises to make some interesting things happen. That was a little bit easier to reason about, but if you look at this is quite a bit of code for something. It's ultimately just a couple of API calls. There's only 2 calls going on. There's some filtering happening here. And even when I was writing this, I fell into this trap of not resolving in the wrong place, or maybe not confused about where I'm returning, because it's not really evident when you look at promises, especially when you've got venables that are chained like this, really where the source of this comes from. Without squinting, you kind of have to look close and say, okay, no, I'm getting the ID here. That must be the device ID. And I think this is where promises actually start to cause a bit of a problem, which is what we're going to talk about right now. Because there is no doubt that promises are a big improvement on callbacks. They help manage a lot of that state for us. But like I just showed, they can be confusing. They can be hard to reason about. They can be hard to maintain at times. Because ultimately, we've created syntactic sugar that tries to make our asynchronous code look a little bit more synchronous, but we still have those dependencies to manage in our own heads. And there's lots of things in the promises spec that make this easier. We talked about venables. When you're working with things where you have a bunch of promises that need to occur in parallel, you can actually do promise.all, which I show on the bottom, or promise.race if you just want to allow things to finish in parallel as quickly as possible. So you have ways to work with this, but ultimately, again, as with callbacks, we've known for a while now that this was a step in the right direction, but that there was more that we could do. And so to tell this part of the story, I'm actually going to take a bit of a detour into ES6 iterators and generators. Now, iterators are an interesting concept because we have a lot in JavaScript today for working with objects. Most programming languages, a lot of what we do is working with collections of objects and iterating over collections of objects. And JavaScript is no different. We have for each. We have for loops. We have now in ECMAScript 6, we have maps and sets and filtering on arrays. And these are all wonderful language features, but we also have something called an iterator. And an iterator is a kind of object that when you're working with certain types of collections, especially an array, and you're iterating over an array, as the caller of the array or the person that is working with it, it's usually your responsibility to do length checking so that you don't overflow the array. Iterators actually simplify this where they maintain the internal state of the array. So instead of doing a loop directly over an array, you can just call next on the array and get the value. And it continues to iterate as long as there's another item in the collection. And when it's done, it returns false. You don't manage the length. You don't have to do any of that checking. It manages it for you. Now, the difference here is you've ultimately just deferred the management of the length of the array, and that checking still happens. It just happens inside of the iterator object itself. So generators actually simplify this by adding built-in functionality in JavaScript where the language itself or the generator object itself will maintain its own internal state for you. And the way that you can leverage this is with a couple of new language syntax features, the function star syntax and then the yield keyword. So anything that you decorate with function star is a generator. And then the yield keyword is basically your way of saying pause execution here. When you yield, you're basically returning to the caller and saying, I'm done now. This is a new concept in JavaScript. It's the first time that we've gotten something where we're actually, not everything inside that function executes until we continue to call it, right? And in this example, what I've created is an ID generator, which gives me basically a random number based between 0 and a max that gets passed in. And then every time I call next, that while loop goes. So I actually do have an infinite loop here, but it's an infinite loop that will only ever execute if you continue to call next, next, next. Every time I call next, what happens is it enters the function, and then it gives me the next value based on the max that has been set when I first created the generator. And it just stops. It yields, waits, hits the start of the while loop, yields again, gives me a number. The next time I call next.value, gets another number, pauses at yield, waits again for the next time. So that's an interesting. What's cool about this and where we can actually create a little bit of a hack is that we can actually take this concept and leverage it ourselves to create synchronous looking Ajax code. So I did this, and in the context of this little demo, what I created basically was a generator function called steps. And inside of that, I have three Ajax calls that I want to run asynchronously. I have 3 that happen, and I've done some console logging here so you'll be able to see what happens. And what I'm doing here is I'm yielding the result of a custom Ajax function that I've called. And inside that custom Ajax function, hey, what do you know? I've got promises. So I actually am calling the native fetch object. In the browser, I'm getting the JSON from the response, and then I'm calling callsGenerator.next. And what this does effectively was, what happens when I kick this off down at the bottom is I instantiate the object, I call next to kick things off, and it goes here, it logs, and then it calls this first Ajax function. That Ajax function gets the data, passes its result back, and then calls the next function. It calls next again on the generator, which steps down to the next yield, returns, and all the way down towards the end. Take a second to wrap your head around, but ultimately what happens is instead of me having to create callbacks or to use promises inside of this function, I'm basically saying, look, I'm writing this asynchronous code. Make this Ajax call and give me the result here in this variable. And then when I log this out to the console, what I end up getting is, I'm going to go into the actual correct place here, fetching the list of beers, fetching information about me, and then fetching band information, and that happens again. It's all happening in promises, but I was able to create something that, to me, looks a little bit more asynchronous. Now, thankfully, this totally contrived demo that I showed you is something that you never, ever have to use because we have built-in language features for this now in ES7, and it's available in most of the browsers. But I showed that to you for a reason. Because promises, and I said this a little bit, let me underscore it again, promises are effectively just structured callbacks where the state of those callbacks is managed for you. Async await, new language features, are very similar to combining this concept of generators where you're pausing execution to wait for a result and the concept of promises. So the two do work together. It's our way of saying promises were a great step, but we can go further and create something that is even easier to manage. And the way that this works is with 2 new keywords. The async keyword, which you'll notice on the inside of that promise function, and then await. Now, one important thing to note here about async await is that you have to use the async keyword in order to use the await keyword, and you have to use async on functions. So you can't just use an await keyword outside in global scope. It has to be in the context of a function that allows you to do async. That's step 1. And the second is you can only use await on functions that return promise objects. So you are ultimately wrapping promises in more syntactic sugar. But because my list devices method is promise-based, I can call await on that. And look it's hard. I mean, I don't want to make too fine a point of it. I think this is actually fantastic that we can get code now that's a little bit easier to reason about about what's happening and what the actual result of my promise-based code needs to be. I want devices in a devices array. I want an individual device. I want the names of those functions. I want you to call that function, etc. And all of those things can be used with those keywords. And just as with promises, as of the last year or so, we now have support for async await in all browsers not named Internet Explorer. And I don't know why, I got this from MDN, but it's also been available in Node since 7.6. And we're at, I think, Node 8 and LTS now, so it's widely available in most implementations of Node. So I want to show you a quick demo of that, because ultimately what I wanted to do, and I showed you this earlier, this is an area where promises can get a little bit complicated, is if we scroll further down, the same implementation with async await fits on my single screen here. We can actually see what's going on and know the sequence of events that are happening. So my device function's async. I'm getting the device name. Again, I'm passing in the device name. I'm doing the same things that I did before, but now, instead of doing a bunch of thenables, I'm calling list devices and I'm waiting for the result, because that's what needs to happen now. I can block execution. I want to wait for the result of this. Same, I filter the devices. I can await to get the device details and then log those out to the console. And just to prove to you that this actually does work, I'll run the same thing again, and I get the same. I get exactly what I expect. Again, shorter, easier to reason about, and I think this is actually a fantastic improvement in the language. Now, one thing that is different, and I haven't covered this explicitly yet, is how you handle errors. Now, you had, in the context of promises, a catch, the ability to log, the ability to catch errors at the end of your scope that way. What we do in the context of async await may sound like it's a little bit old school, but I think ultimately this is nice, is we use try catch. So hold on. So the way that this works then, when I'm inside of an async method, is I just wrap that in a try catch block. So if I have anything that happens, and I have just totally lost control of my keyboard. Cool. All right, so I won't show you, but you can use your imaginations. I will wrap this in a try catch, so if an error happens, I don't get unhandled exceptions, and that actually works out quite well. So the takeaway for all of this is really three things. I'm really getting like nothing working here. This is the weirdest thing I have ever experienced. All right, I'll just show you the whole slide right here. Don't ever use callbacks. In many cases, definitely don't implement callbacks yourselves. Use promises as much as possible. If you're implementing something that still relies on callbacks, wrap it. Wrap it with promises. It'll be easier for you to maintain a promise. And then use promises as much as possible in your own code. And then definitely use async await as much as possible as well. It can take a little bit to get used to, but I promise you it is worthwhile. It is really easy to use once you get going with it. And it's fun. It actually makes, it's one of the language features in JavaScript that I've loved the most over the course of the last several years with async and await. So that's all I had. Is there any questions? Anything I can dig into more on async await or promises? No? All right. Thank you all for your time. Enjoy the rest of the conference.